All right, welcome back, Art22. So in this second part of our um, Class 1 Week 3 lecture, we're going to add just one more small element to our movement, but then we're also going to take a moment to focus on how we can make our code a little bit more legible and a little bit cleaner by creating our own functions. So we're basically going to package parts of our code into think about it like how on your computer it would be a total mess, right? If you didn't have any folders, it was just files everywhere. But to keep things organized, we have folders that we place all of our files in. We're going to do the same thing with our code. We're going to take little sections and we're going to put those into a function, kind of like a folder, and then we'll see how that will just help clean things up quite a bit. But we'll get to that at the end. The first thing I want to do is take exactly the sketch that we had just been working on in Week 3, Class 1A, the lecture before this, and just add one more element. And before we even get into that, let's draw out what we're looking to do here. So what we had in the last lecture was the ability to have velocity and direction informing the motion of our geometry. So our ellipse was maybe moving a certain amount in the x, with a certain amount of x velocity or y velocity and in a certain direction. And when it hit the screen, can I get there? There we go. It would bounce to the other side. Now we want to add one more thing just to spice things up a little bit, which is adding this almost like gravity to it as well, or acceleration if you want to think about it that way. So what we're going to do is add, it can be in any direction we want. We'll start with kind of replicating what Earth gravity looks like, but then we can change things around. So we're going to add a gravity variable, and we're going to see how that works. But let's first just draw out what we're hoping to do. So, here is our window. Okay. So what we saw before was that we had, our ellipse, and it was kind of moving in straight lines. Something like that, right? Cool. So let me get rid of that for a second. Okay. But what we want to do is to have more of an kind of an arc to it, kind of a parabolic motion. So we have, think about like if you had a ball, right? And think about physics class from high school or whatever. You throw a ball in the air. It doesn't go until it hits, the border of the earth or whatever and bounce back. It goes up with whatever initial velocity we throw this ball at, whatever speed per second. And then because there's gravity on Earth that's pulling it down, it slowly gets like, you can imagine that nice arcing shape, like someone throwing a ball or something like that. So what we want to have happen is we have some initial, let's say, y velocity that's going up, this way. But because we're going to have some gravity, it's going to look more like this. We're still having our direction change. So we're going to get something like that. So luckily, that's a pretty easy thing to add to our code. So let's go ahead and look at that, and then we'll talk about this whole idea of cleaning up our code, because as you can see, things are going to get a little bit crowded in our draw loop, and we want to clean that up a bit. So let's add some gravity to this whole movement situation. Okay. So what I've done is I've taken our sketch from the previous lecture, and I've just said File, Save As. Make sure you save the Class 1A version first. Once that's saved, then go to File, Save As, and change the name to what I did here, which was Week 3, Class 1B. So now we have this sketch that is the same as the other one, but now it's saved as a different name so that we can edit this one and keep the Class 1A version still up and running. Okay, so what I want to do is, first things first, I think if we start introducing gravity into this kind of one line, it's going to start to get confusing, and maybe it's already a little confusing. So I think it would be a good idea to separate some of this out and make it a bit more clear. So what I'm going to do, let's just start with the idea of we're going to add gravity in the y direction, which you remember is the vertical direction, so that kind of makes sense, right? It's sort of like Earth's gravity, right, where things are always pulling down. So first things first, let's just kind of unpack this line a little bit and make it a bit more explicit. So instead of saying this, I'm going to break this down into a couple lines that will end up having the same result, but I think will maybe be a bit more clear. So what we're going to say is y velocity is equal to y velocity times y direction. So we had kind of already built that into this a little bit, but here we're just making it explicit that we want to make sure our velocity is going in whatever correct direction we have based on our step down here. So this is nothing new, I'm just rewriting it in a way that maybe will make it a bit more clear. So make sure y velocity is in correct direction. So either up or down. Up or down. Okay. Now what we can do is we can do y pos, so our y position is going to be, we're going to add the y velocity to that. So we're going to say plus equals y velocity. So add y velocity to our y position. Okay. So now that that's there, I'm going to get rid of this line. Okay. So we have some velocity, which starting off at 3 pixels per frame is the velocity. The direction, which starts off as +1, so that means we're starting off going down at 3 pixels per frame. So we're setting the direction and the velocity, and then we're adding that velocity to our position, which is what actually makes the movement happen. So nothing new here, just rewriting that a bit. All right, so I keep saying that we want to have some gravity to this. So let's go ahead and first make those variables for gravity. So just like we had position, velocity, direction, we want a variable for gravity. So we'll say x gravity and y gravity. You could also call this acceleration if you wanted, but totally up to you. So I'm going to say, how about acceleration variables? There we go, best of both worlds. All right, so we need to initially set these up. So why don't we go with x gravity. Let's have no gravity in the x direction for the moment. And let's have y gravity. I just happen to know that something like this will work out pretty well for us. So initial x gravity. I'll keep it consistent here. Acceleration. Initial y acceleration. Okay. So now we need to add this gravity into our movement scheme over here. And luckily, that's actually pretty easy to do. So let's do a little bit of a before and after here. So we have our ellipse that's kind of moving in a diagonal straight line. But what we're going to start doing now is adding this pull downward, this acceleration, this acceleration or gravity in the downward direction. So what I'm going to do is say gravity is 1.2, so we're going to have some downward direction, and downward because it's positive. So we're going to say now to add the gravity into the mix, all we have to say is y velocity plus equals y gravity. So add gravity to velocity. All right, let's check out the effect of that. All right. now we have our bouncing ball. Some crazy behavior. So one thing that we're not going to get into today is this idea of we need to have kind of something they call dampening, which we're just not going to get into. But to make it more realistic, where it got, imagine if you have a normal bouncy ball, it's not going to always bounce as high or keep getting higher. It's actually going to go the other way, right? Where it's going to get, it's going to bounce less and less and less each time. There's something we could do to make that happen, but I don't even really want to go there. I just want to get the sense of that we have this more bouncy-like behavior. Let's take off the background for a second just to see that more clearly. And I'm going to decrease the y velocity to 1. There we go. A little bit easier to see it now. So we're still having our direction change, which is good, but now we also have this velocity thing. So again, you can see, because we haven't implemented our damping situation, that we're going to be a little bit broken, but we're not going to worry about that today. Okay, so what would happen if I wanted, let's say, to have a very strange environment where we had gravity, but it didn't pull us down, but it pulled us up, which would be kind of awesome on Earth. But what we could do is, right now y gravity is positive 1.2. So it means it's going, and we know positive for the vertical axis. Positive in processing is moving downwards. So if we wanted gravity to be going negative, if we wanted to be going up, we just change it to negative. So let's see the effect of that. There we go. All of a sudden we are in the upside down, and our gravity is going in the other direction. Cool. All right. So now let's do something here. I'm going to decrease our y gravity to something like maybe 0.5. Now let's add a little bit of imagine. So sometimes what I like to think about is when we add gravity in the horizontal direction, like left or right. I imagine there's like a gigantic fan that's just blowing into our window here. So let's say that we have a 0.5 gravity, so to the right, because it's positive, a 0.5 gravity to the right. Well, first of all, we need to add that to our mix here. So what I'm going to do is I'm going to get rid of this, our old way to do x position. And I'm just going to copy our y stuff here. So now we can just change all the y's to x's. So this is just doing the same thing we did for y, but now for x. X velocities, x gravities, and x directions. And I'll change our comments to make sure x velocity is the correct direction. In this case, right or left. Add x velocity to our x position, and there we go. Okay, so let's just see what we get now when we have a positive gravity for the x direction, so a little bit to the right and a little bit up for the y direction. There we go. Okay, now we have a whole nother type of motion here. So we can kind of see that we're going up and to the right on this kind of upper right corner, right? We have gravity going up by negative 0.5, and we have gravity going right by 0.5. Let's switch that around. Let's have gravity positive 5, so going down 0.5, and still having it going to the right. There you go. Cool. And then just to illustrate the point fully, I'm going to have no gravity going up or down, but just 0.5 gravity. So just a little bit of gravity going to the right. And there we go. So kind of satisfying to watch. Okay, so again, we're not going to get into the damping thing to make this work a little bit better. I just want to introduce this idea of both velocity and gravity or acceleration, because later we're going to get into the kind of more proper way to do this, where it's not breaking after a little while once we get into this idea of particles. But for now, I just want to leave it at that, just to introduce the concept and let it kind of percolate while we do some other things. So speaking of which, we now want to do the other thing I mentioned, which is just cleaning up our code a little bit. So you can tell that like having everything all together here on one tab, this one tab here called Week3 Class1B, that's kind of a lot. It starts to get really hard to read this, because like, you know, we have all this code, we have all these comments. It's just a little bit much. And so what we can do is we can start to package this parts of our code into sections that make it much more legible. So the way we do that is a kind of three-part process. First, I'm going to make a new tab for each kind of, you can think about like a folder, like each folder of code that I want to move. Then we're going to create a function, and then we're going to call the function. So we'll see what that means in a second. But first things first, let's do, so I'm going to kind of think about our code, just the draw section at least, in kind of like 4 sections. So I think of this section here as like what we're actually drawing. Another way to say that would be like what we're actually rendering. So I'm going to create a section of our code called render, which will be for whatever we're actually drawing to the screen. So this is the first time we're actually saying, hey, draw something on our screen. Put this ellipse, make the stroke, all that good stuff. Now this section I would call kind of like our update section, because we're updating all of our variables. We're saying, okay, x velocity is now this, y position is now that, and then adding gravity. So this is where we're like updating things. This would be something I would say, this is like our section of code about making sure that we're checking our boundaries. And finally, I would say this is like our interactive section of the code where we're using our key pressed. So I'm going to make 4 separate section tabs and functions for render, update, boundary, and interact. We'll call it interaction or something like that. Okay, so first things first, let's see how we actually do this. So I'm going to click on this little arrow. I'm going to say new tab. All right, and I need a name. So it's probably good to name it whatever function we're actually going to be using. So I'm going to say this is going to be called our render. Okay, and there it is. Now, so that was step 1, make the new tab. Step 2 is we need to make a function that's going to store all the stuff that we want to have happen. So what I'm going to say, so in the same way that we have void draw and void setup, those are functions that processing has built in, where we can put a bunch of stuff in here, and we know that processing is going to say, okay, run setup, and it does all that stuff. And now it's going to say run draw over and over and over again, and it's going to do all of this stuff in here. We can make our own functions. So what I'm going to say over here is void, just like in the other ones. But now I'm going to make one called render. Still put our parentheses, still put our curly brackets. So now we have our own, like we defined our own function here called render. And so what we can do is take whatever we want to have happen, which in this case is these 3 lines of code. We want to draw our background or not, and we want to draw our ellipse, and we want to draw it with no stroke. I'm going to copy that, take it out of here, put it in here. Command T to clean it up. Okay, so now we have packaged these 3 lines of code, the stuff that we're actually rendering to our window, things that we're actually drawing, into a function called render. All right, but now what do we do with it? So we have to, now back here in our draw, because this is the function that's running over and over again in our code, we need to tell it to do our render function. So this here says run the render function. So what's going to happen is our draw loop is going to say, okay, do render. And what is render? Ah, it's those 3 lines of code. Cool. So that's all that is. So now let's do this with the other 3 sections of our code. So I mentioned that this I kind of consider like our update section of the code. So I'm going to make a new tab. I'm going to call it update. Update. I'm going to make a new function, void update. Okay. Now I'm going to copy this stuff out of the draw, and I'm going to put it in our update function. Command T to clean it up. And now, just like render, we need to make sure we're calling update. Calling is the way to say actually make the function happen. So update, run, or call, depending, the update function. And what is update? Update is these 6 lines of code that are updating our variables. So again, we've just packaged it in something called update, and then we can use update here. All right, let's do the last 2 here. So I mentioned that this I kind of think about as our boundaries. So I'm going to make a new tab called boundaries. And I'm going to say void boundaries, just like the others. And we are going to paste in this whole section here. There we go. Clean it up with Command T. And once more, we just need to call our boundaries function. Boundaries. You get the idea. All right, last one here. So we're going to do our interaction function, which is how we're interacting with our code, which is through this key pressed. So let's make a new tab. I'm going to call it interaction. And once more, we will make a new function called interaction. Cool. And let's go ahead and copy and get that part of the code out of there. Interaction, there you are. Command T. There we have an interaction function. Same thing there. I'm just going to get rid of this. Okay. So now, I'm going to save this. Now this looks way cleaner to me. In general, I think it's a great practice to have your draw function be as clean and clear as possible. Because imagine that you're handing this code to someone that wasn't familiar with it. They would see, okay, what is our draw loop doing? All right, so we're rendering some stuff. I don't know exactly what. We're doing some updates. There's some kind of boundaries happening, and we have some interaction in this code. So this is definitely, I think, more legible to me as code, and also for you when you want to expand this or edit it later. You don't have to dig through like a whole entire page of tons and tons of code. You can be like, oh, I need to adjust the interaction. Boom. Or, okay, I want to change the way, I want it to be a rectangle now. So I'm going to go to render where we're actually changing the shapes. And if we run this, we can still see we're going to get the same behavior. We still have everything working the same. It's just now been packaged in this way. And if you really wanted to go crazy with this, you could do one more even, which would be to put all of this section of code into something called like initialize. So why don't we do that just for good measure? I'm going to say a new tab. And just to shorten initialize, I'm going to call it init, I-N-I-T. Void init, initialize. And I'm going to put all this into our initialize function. Command T to clean it up. And then we just have to make sure we call that function. So init. And let's confirm that this still works. And there we go. Great. So to me, this is much nicer to have a very clean first page of our code with all these functions, and then within them, they are grouped by kind of topics. So I highly encourage you to go about your code in the future with this. But for now, that is where we will leave it. And in the next 2 lectures for this week, we're going to be talking about 2 more interesting forms of motion that are a bit more organic and a bit more random. So hopefully we'll look forward to that soon. All right, bye everyone.